Today, we're going to talk about energy and different forms of energy. Now, everything in the world uses energy. You guys just watched Bill Nye, and he talked about all different types of energy. Now, all of those different types of energy fall into two different categories. Those categories are potential energy and kinetic energy. You can see this graphic to the right here, and we have two different types of energy, potential and kinetic, and then the types of energy that kind of fall into those categories. Now, potential energy is stored energy and kinetic energy is the energy of motion. Today, we're going to talk about different types of these things and how they are defined. So, potential energy, like I said, is stored energy. Now, an object will store energy because of its position. There are four different types of potential energy gravitational potential energy. So, we can see that this boy is holding a brick off of the ground. That brick is a certain height off of the ground. Now, we know that when something is on the earth, the force of gravity acts on that object. If he lets that brick go, it's going to fall down towards the ground because of that force of gravity. So that's why this is called gravitational potential energy. We also have elastic potential energy. Now, with the slingshot at the very top right here, when this is pulled back, it's then in a different position compared to its original position. So it has stored energy in there because of its position. Then, when it's let go, that object flies forward because the energy is converted from elastic potential to kinetic. But we'll talk more about that later. So that's elastic potential energy from elastic materials. We also have chemical energy and nuclear energy. Now, we're mostly going to be talking about gravitational potential energy and elastic potential energy in this class. And I'll go into detail, a little bit more detail with all these things. But don't worry too much about chemical and nuclear energy. So, gravitational potential energy, like I said before, is the potential energy due to elevated positions. So, like that boy had the brick off of the ground, right? That's called gravitational potential energy. Now, the main thing that I want you to remember with this is that the higher something is from the ground, the more potential energy it has. All right. So, the higher the height, the more gravitational potential energy the object has. Now, elastic potential energy, like we talked about before, is when a spring or another elastic material is stretched or compressed. That's when it has stored energy. All elastic materials have like a normal state, which we can see at the top of this graphic right here. We call that the equilibrium position, which means that it doesn't have stored energy. Right. As soon as you stretch it out, though, you are changing the position or the configuration of that spring, and therefore the spring is now storing energy because it wants to spring back to its normal relaxed equilibrium position. The same thing happens when you compress the spring, right? It again wants to spring back to its normal equilibrium position. So you store energy when the spring is compressed as well. Anything that has elastic properties, so like springs, rubber bands, slingshots, trampolines, bouncy balls, tennis balls, pogo sticks, etc., so many different things. Those are all things that can exhibit that elastic potential energy. All right. And then, like I said, there are two other types of potential energy. We have chemical potential energy, which is just the energy that's stored in chemical bonds. When chemical bonds are broken and reformed into different configurations, some bonds have more or less energy than others. So, something like our food is an example of chemical potential energy because we can eat that food and then our bodies can convert it to other types of energy. Another example is nuclear potential energy, and this has to do with the particles in the nucleus, the protons and neutrons, and how they interact and are just configured in the nucleus. Again, we're not going to go into too much detail here. Just know that these are other types of potential energy. Now, kinetic energy is just the energy of motion. So, the main idea here is we want to just remember that in order to have kinetic energy, an object has to be moving, it has to have a velocity. So, if something is at rest, it has no kinetic energy. All right. Now, there's different types of kinetic energy, and this just has to do with the motion of particles and of objects. So, something like this race car right here, we would say that it has mechanical kinetic energy. Now, we usually just simplify this and just say that it has kinetic energy in general. But we We specify here saying mechanical energy because there's a lot of different types of energy that are considered types of kinetic energy. So, something that's moving, we have mechanical kinetic energy. Electrical energy is also considered kinetic energy because really what electricity is it's just electrons flowing through a wire. That's the flow of electricity. So, since those electrons are moving, that's also considered a type of kinetic energy. Thermal energy is also considered a type of kinetic energy because the hotter something is, it's because the particles in that object, the little atoms, they're vibrating. The hotter something is, the faster they're vibrating, and that's what makes the object hot. Sound energy is also considered a type of kinetic energy because when you hear sounds, it's because the particles in the air are moving back and forth. They're getting compressed and then they're getting kind of spread out. We call those compressions and rarefactions. Those sound waves are then hitting your eardrum and vibrating your eardrum back and forth and sending signals to your brain, and that's why you hear sounds. All right.